All right, so welcome everyone. So today we are looking at a simulation on Aspen Plus. Now this is just to make you get familiar with the system a little bit. It's just a very basic thing we're going to be doing, and then today we'll be looking at how to heat water. So what we are just going to be doing here, I'm just going to show you how to add the components. From the previous video, we've already seen a little bit of how to add components. All right, so we're just going to do almost the same thing, but we'll not be working with a unit operation, and then from there I'm going to show you how to check your results and few other things that you should just be aware of. All right, so let's start with our component list. Now I told you I just trying to learn how to heat up water. All right, so let's move into it. So we select water as our component, so I just type in water. That's another way of putting my component in it. All right, and I leave it on conventional. Remember that's the standard liquid, right? Conventional usually is mostly in liquid form of water. All right, so yeah, and then the joy of Aspen Plus, which I must really add, is that it helps you to run simulations on solid. All right, so I can decide, like we did in the previous video. I told you you can select non-conventional solids and have a particular solid component itself. So maybe if you are going to be dealing with things like biomasses, maybe you are trying to simulate corn and all those things, you can actually do that on Aspen Plus. All right, but you'll be needing your proximate and ultimate analysis, and some, if you're going to be doing things like grinding and all that, you're going to be needing some PSD analysis. All right, so you'll be needing some of those parameters for that as well. All right, that's particle size distribution. All right, so let's go to the next thing. So after you put in water, you click on next. All right, so you select the base method you want to use. For this we could just use okay, can decide to use RTL. I can decide to use thermodynamic properties for water, or just depending on what I want to do. That's IAPW Earth 25 95. All right, but let me show you how to make use of your method assistant. All right, so in a situation where I don't know what to use for the simulation now, I can come to my method assistant. Okay, just wait a little bit for it to come up. Okay. Hmm. All right, so from here you can see property method selection assistant. All right, it says welcome to property method selection assistant. The purpose of the assistant is to help you select the appropriate property method for use with Aspen Plus and Aspen properties. All right, the assistant will ask you a number of questions, which it uses a suggestion, a suggest, which you use to suggest one or more property method to use. All right, so start by selecting one of the following options. So what are we doing here? What are we trying to achieve? Let's see what the specified component type looks like. All right, so this is select the type of component system. Is it chemical system? Is it hydrocarbon system? Special, like water only, amines, salt water, um carboxylic acid, HF, electrolytes and all that. But this is containing what we want, water only, so we select this. All right, this is select one of the special systems of components. All right, so from here, um just select water only. All right, you see, so use one of the steam table methods. So we can use steam ta, that's table ASME. All right, and then say you can use the 1967. So basically these are the things you can use for it. Remember, I wanted to use this one before for mine. All right, so but these are other methods you can use for it. All right, then you can see the following help topics for additional information concerning the method you want to use. All right, so let's say we're checking this one out now. All right, so it gives you details about this particular method to use. All right, so what this IAPWS stands for now is International Association for the Properties of Water and Steam. Okay, so it replaces the previous 1984 formulation. When I remember, this is 1995. All right, so it replaced the one of 1984. That's IAPS. All right, so it just gives you a breakdown of what it's all about, of what this particular property is all about. All right, this method, sorry, this method is all about. So that's basically what's happening here. All right, so I want to make use of my method, this. All right, so having done that, I click on next, and then the simulation is telling me that okay, I can run the property analysis for this now. And I said okay. All right, so having done that, you can see that the table generation begins, table generation completed. All right, so whenever your component is okay, the analysis is okay, everything is fine, it's converged, all the properties that is needed to go further is being gotten, you see your result available here. All right, whenever you see results available here, it means your system is good to go, it's converged, and then you can move forward. If there was an error warning sign, you see the warning sign, and then from here to show you the message where this warning is coming from and what you are required to look at. All right, maybe you'll be required to give some specifications, maybe some properties might be having missing IDs or missing uh, values, so you will be required to put in those values, all right, before you can go further. Or you can see an outright error message there, meaning that it's there's a problem in a particular property. You might have to review that or change your method, or you go to estimation whatsoever, just to make sure you resolve the problem before you go further, because it's going to definitely affect your calculations in your simulation. All right, so it's always best to use the appropriate method. All right, and then so that like I said, the method and your component, they go together, and the process you're trying to achieve as well. All right, so when this is done, then you can now go to your simulation. All right, normally you can go to your simulation without even finishing up your property. All right, I said that in the previous video. Right, so from here we see that we have flow sheet not complete. That why? Because I haven't added anything to my flow sheet here. All right, so the first thing I'm going to be putting in is my stream. Remember, we're trying to heat up water. Then I will go to my exchangers. I select my heater, drop my heater here. That's it. All right, I want to connect my first stream to it. So this is how you do the connection. You double click on the arrow going out and connect it. All right, And then if I want to get my stream coming out, I select my material stream. You see it offers me options on where I want to place this material stream on my heater. Alright, and then your heater, it requires you to have an inlet, and that's the feed, and then an outlet, that's the product. Alright, so I select my product and I drop this. Okay, so I can decide to change the name here. Instead of S1, I can decide to put water in. Alright, and the thing with this Aspen Plus is that this particular character, it has a limit. Yes, it has a limit of 8 characters. I can't go beyond 8 characters. See, it's already giving me a message I can't go beyond that. So I put in water out. Alright, then my B1, same thing too, it also has its limits. So I put in water here, heater, sorry. Okay, so now I just want to raise the temperature. Let's Now I need to do my specifications. Remember I told you from here, see under streams, the streams are added. It's already showing here. Alright, then the block, my heater, it's already showing here. Alright, so now from here it's already saying that required input is incomplete. Alright, why? Because I've not added the specifications needed. But initially it was showing flow sheet incomplete because I have not added anything to my flow sheet. Alright, but now I've added something, and then now it has changed from flow sheet incomplete to required input incomplete. So I now go to my water in. I need to specify the flow rate, temperature, pressure, and also for this I'm going to making use of, let's say it's going in at 25 degrees Celsius, and you can say 1 atm. Alright, so that's it. Then let's say I'm using the volume, having 20 liters per minute. Alright, so from here what I just need to do, instead of me specifying the mole flow, since I've done that already here, that's my volume, I just need to go to standard volume fraction and then select water, make this one. Alright, so it basically almost the same with Aspen ICs. You can see that it has a mass flow. Whenever you put in your mass flow, mole flow, or standard volume flow, most times it's not required of you to add this anymore to it. Alright, you can just go ahead and put in the value for that particular component or composition. Alright, so for this now, I added it here, so I don't need to select this. What I need to be looking at now is the fraction. Alright, so that's why I selected the standard volume fraction for it. Or if you have a concentration, mass and mole concentration, then you can add that to it here. Alright, so going forward, this stream is complete. Whenever your stream is fully ready, you see the tick on it, this blue tick, input complete, everything is completed. So then you can move on. Alright, now the next thing I need to take care of is my heater. Alright, so in my heater, I'm just trying to increase the temperature to about 70. Alright, and then from here, I can decide to see there's no pressure drop. Now, if I see there's no pressure drop, I'm going to put in 0 at this point. Alright, but if I say there is a pressure drop, or then have to specify the pressure which my outlet is going to be coming out. Alright, so let's say, remember it's 1 atm. I can decide to put 1.0 this is 0.5. But normally if you're increasing your pressure, definitely there should be an increase. If you're increasing temperature, most times there's always an increase in pressure you get. So basically let's just do what's right. Alright, so let's increase our pressure to about 1.2 atm. Okay, so apart from in just the temperature. You see all the parameters here. You can see temperature change, degree of superheating, degree of supercooling. Um, Now this particular heater here can also serve as a cooler as well. Forget that the name here is just heater, but it can also be used as your cooler. All right, it can also be used as your cooler. That's why I've seen this degree of subcooling. So if I want to reduce the temperature, I can still do that with this particular unit. All right, then so maybe if you are doing any operation that requires you to make use of a cooler and you don't see a cooler, don't panic. All you just need to do is to select your heater and give it the specification you need. All right, so I'm going to be doing the cooling process of this heated water so that you can see that it's still the same unit operation I'm going to be using for it. All right, so let's move on. Okay, valid phases, vapor and liquid. Yeah, I can leave that, or I can select it if it's only solid, but we're not using that if it's only liquid. But in this our heater, by the time you definitely hit the temperature of your water, you'll be having vapor and liquid, so you need to take account of that. All right, so let's move on now. Having done that, you see required input is complete. My block is ticked. All I just need to do now is to run. Click on run. Okay, see result now is available, meaning the system is converged, everything is working. So to check my results, now I can check my results of the heater. I go to the block here. Upon that blocks, I go to results. That is just checking the information for my heater, that unit operation. I can see my outlet temperature is 70, outlet pressure is 1.2. I can change it to ATM so I can see it in ATM. Alright, 1.2 ATM. Vapor fraction is 0. Heat duty, this is the heat duty of my heat exchanger. And pressure drop was minus 0.2, meaning that when you see this, it was actually like a pressure increase, not a drop anymore. Alright, so I can check my balance. Okay, so I can see that my inlet mass balance is okay. Inlet is equal to outlet. I can see my energy balance too is okay, just a little bit different. I can see my mole balance too is fine. Say this is 0. So whenever your heater is okay, you see this blue tick here, and that's why you also see this blue tick here, so meaning that everything is okay. They said block calculation was completed normally. All right, so this is your convergence status. All right, property calculations were also completed normally. So now if I want to check my results of this particular unit, now your result shows you the overall energy and material balance. All right, so it's showing me my water in, my water out. That is, I'm checking it from the block. All right, I'm checking it from the block, so I can see liquid phase. Okay, saying both of them are both in liquid phase, liquid phase, liquid phase. The vapor fraction of this is 0, 0, liquid fraction 1, 1. Okay, you can see all that thing: molar enthalpy, mass enthalpy, molar density, mass density, enthalpy flow. So you can basically get your information from here. You can see the molecular weight of the water. Let's say I had other things inside this particular stream, it could also give me the average molecular weight based on all the components that are in it. So my mole flow, this is it here. My mass flow, this is it. The volume flow, this is it. All right, and then I can decide to check this. I can decide to check this. All right, so depending on what you're looking for, this is how you see the results of your stream or your unit operations. All right, so going back, like I said, I'm going to cool this back down. Okay, let me come to, yes, this place here. So remember we were trying to increase the temperature of the water, and that is what we succeeded in doing. With the heater, moved it to 70, this water out. So now let's bring it back down. So I select my heater again, drop it. Okay, all right, before I come here, I need to connect this. So put, connect it here, and then my outlets, select my material stream and drop it out. Okay, then I just need to get my temperature, bringing it back down to 25. I'm cooling it, it's going back to 1 atm. All right, so once I'm done with that, I just need to change the name. It's showing block B2 here. That's because of that was here, so I can change it to cooler, and I can change this to code H2O. All right, so once I'm done, whenever you are done with your inputs, most times this here is always active for you to run. Whenever this is not active, it means that there's a specification that has not been given yet. There's a particular input you've not given to your simulation. So most times you just click on this next first before so to direct you to where you've not yet given the input for your simulation. All right, so once I click on next, it tells me that all required input is complete. You can run simulation now or enter more input. All right, but all the required input to run the simulation at this moment is complete. So I click on OK for it to run, and then it's running. Okay, so at this point here, it shows you the sequence of how it's been solved. All right, it's first solve the heater before going to the cooler. All right, you see no error was issued during the inputs, no error or warning message was issued during the simulation. All right, so this is from my control panel. This message is coming from my control panel. All right, so let's move on back to the simulation. Now to check my cold water, I just go to my cooler. I can check my results from here, and then I can see my inlet, I can see my outlet pressure, I can see the heat duty at this point. We can also compare heat duty. So let's see the heat duty from the heater on that results. Okay, so this is it here. Well, this is okay, this is 14,940, 140.9. Okay, while for my cooler, I can see that this is minus. All right, this is in minus, this other one was in plus, meaning that you needed energy. This one you're removing energy from it. All right, so let's move on to the stream results. So we can see that this is water out, that is what was going into the cooler, and then you can see from the heater to the cooler, and then this one is from the cooler. All right, so we can see that we've succeeded in bringing back the temperature of the water to 25, and then you can also just check our mass flow, volume flow, and all that. All right, so it's basically going to be the same. Now if I need to compare all results, I just need to click on this drop down button here. I can select my water in, and then I can check that stream as well. All right, so basically that is how you go about heating of water. But basically what I'm just trying to show you here is how to just set up a simple simulation on Aspen Plus. All right, how you connect to streams, how you give your specifications required for your simulation to be complete, how to know your simulation is complete, and where to check for error messages. Your error messages will come here. You can easily check the status. Error messages come here. If there was an error in this simulation, definitely it will have shown me here instead of just results available. Alright, so basically that is how you run a simple simulation on Aspen Plus. Alright, so this is still an introduction to Aspen Plus. Alright, so see you in the next video. Thank you.